Hello Year 10. Today we're going to be doing about types of wave. So I'm just going to go, here's the work folder. This is the new topic. We're moving on to waves now. This wave info in here is, because there's a lot of information to cover. Now the information itself is not difficult. It's a lot of knowledge. So the first lesson is really just, I'm going to tell you a lot of stuff and you've got to make notes and remember it. You'll see quite a lot of this should be familiar. It comes from what we've done already in Key Stage 3. But before we can move on to the rest of the topic, you've got to make sure you absolutely know the difference between longitudinal, transverse waves, how to draw them, how to measure their wavelength, etc. And after that we'll move on to wave speed and the required practical. So I'm just going to move straight onto it. Okay, so today's lesson will be mostly you're taking notes, because the only questions I can ask are describe certain types of waves, and it's a standard answer. And again, I've said this before, the difference between a grade 5 and 6 student and a grade 9 student is the grade 9 student will remember standard answers. They might not necessarily be any cleverer. It's just that they go out and they drill those definitions and those answers and they can just repeat them word for word. Now, just pause it quickly. How many waves can you think of, and what do waves carry? So, we're going to go over a few different examples of waves. Hopefully we know that all waves carry energy. Okay, they carry the energy from one place to another. They do not carry matter or stuff. Now let's go straight onto it. So sound waves are an example of a wave. They are a mechanical wave, which means they travel through a medium, for example air or a table or any form of matter. Sound waves are longitudinal. Now if you look at the wave, so my cursor is going to follow a wave. So here's a wave, you can see my cursor is following it. You see the wave is moving down, right? So the wave direction is moving to the right. Now if I follow just a single dot, see this dot here? It's vibrating to the right and to the left. You see that? The dot itself isn't moving very far, but it's moving from right to left to right to left. And then the wave itself moves right. So those particles are all vibrating parallel to the direction of the wave, or, as I like to say, a longitudinal wave. The vibrations are along the wave directions. Now, let's move on to light. Light is an electromagnetic wave. Okay. Electromagnetic waves travel through a vacuum, which means they do not need any form of matter to be able to travel from one place to another. And some electromagnetic waves can even pierce through matter. Give you an example. If you look out your window, you can see outside because the light waves can move through the window. Let's take X-rays. They can go through your body to give yourself an X-ray. Now, light waves are transverse. They vibrate perpendicular to the direction of the wave. For some reason, the animation doesn't seem to be working. But what will happen is the light will be moving to the right, and the energy, say if we've got water, let's take a water wave for an example. If next time you go in the bath or you look in the sink, just do a water ripple, you'll see the ripples move out. If you were able to look at it very closely, what we'd find is the water ripples will move to the right. So the wave itself moves to the right, like a Mexican wave. But the actual particles themselves will vibrate up and down. So if you go on YouTube and you Google Mexican wave, there's a really good one where they're on the football stadium, they'll do the Mexican wave all the way around. You'll be able to see the wave move around the stadium, but the people themselves don't move. They just stand up and sit back down. So they are moving perpendicular or at 90 degrees to the direction of the wave. Now, here are those definitions again, because we absolutely need to be able to just remember these. And the two most important ones I would say are these two, because they're more difficult. So longitudinal waves. Here, wave vibrations are parallel to the direction of the wave, or longitudinal waves, the vibrations are along the direction of the wave. And that's how I like to remember it, because it's longitudinal, so the vibrations are along the direction of the wave. Transverse waves, the vibrations are perpendicular to the direction that the wave travels, or the vibrations are 90 degrees to the direction that the wave travels. So there is another way of wording it. I've already said that with my voice, so I'm not, you can pause it and read it if you'd like to. Here it is them side by side. So here's a speaker, and you can, before, it's not an animation, but remember the particles vibrate to the right and left, but the wave itself travels this way. So if we look at a light wave, okay, we're going to learn a little bit more about the electromagnetic spectrum. You'll see the wave looks like an S, okay. The wave itself, if you put it sideways, it looks like an S because it is a transverse wave. And the wave moves to the right, but what happens is these peaks and troughs will move up and down, okay? So the wave direction is to the right, but the wave vibrations are up and down. They are 90 degrees. Now, this links into the electromagnetic spectrum, which we will go on to later, so I'm not going to stay on this slide. But here are some examples. Transverse waves. Best way to identify a transverse wave, because there are lots of S's in transverse, is if the wave looks a little bit like an S, okay, it's wiggly like an S, it's a transverse wave. So, water waves, an oscillating string, seismic S waves, light waves. A longitudinal wave, okay, sound waves, pressure waves, seismic P waves, which we will learn about later, all these ones that you've never heard of before. Notice that light's an electromagnetic wave, okay, but all the other ones here are mechanical waves. So light is the only electromagnetic wave here. All the other ones that are listed are mechanical waves because they need a medium to travel through. Now, to make sure you absolutely understand everything that's done so far, because there's a lot of information that I've just sort of thrown at you very quickly, so please pause the video and go back if you need it. You need to be able to talk about a wave. So what are they and what do they carry? Waves are vibrations, they carry energy. You absolutely need to know that. Describing a transverse and longitudinal wave. We need to get, I would stick with the medium for now. We'll leave out compressions and rarefactions until a bit later. Stick with the medium. Make sure you know how to draw a transverse wave and label the wavelength, the amplitude, etc. Okay, if you're not sure, go onto the help sheet that I linked. That's a very classic question. Draw and label a transverse wave. Then give me an example. Make sure you know how to describe the vibrations. The same for longitudinal. Make sure you can describe the direction of the wave travel and the vibrations. That is the bread and butter. Then, we are going to move on to water waves and the required practical. Very quickly then, pause the video, have a little think. What do you need? What information do you need to calculate the speed of those waves? Okay, let's continue. Now, some videos I'd like you to watch. The top one here from the Open University is about 10-year-old, but the explanation that the person gives and the equipment that he's got is really good, so it is definitely worth a watch. Fortunately, I can't demonstrate anything because I'm at home. Now, the next video as well here, this is from a school. Again, she talks more specifically about the required practical, and it's a good video to watch. So please watch these 2 videos. The last one is the science guy, the one with the blue background. So if you're really still stuck and don't understand what on earth's going on, watch him too. I promise you, as lessons go on, because this is all just a knowledge lesson, it's just all you need to learn, all these things I've told you, you will start to tie them in later and it'll all start to make a bit more sense. Now, another thing we need to learn or know is about the superposition of waves. What happens is if you get 2 different waves and put them towards each other, they will interfere with each other. Now you look here, you can see there are some lines coming out that look like dead, and there are some lines coming out that look very pronounced. So what's happening here is these 2 waves are interfering. Okay? If you get 2 waves where their peaks and their troughs match up, you see here the peak of wave 1 and wave 2 matches up, and the trough of wave 1 and wave 2 matches up, they will add together. So the wave that they add together to make will be twice as big. So where you've got this wave source and this wave source here, what happens is where in the middle here, where the peaks and troughs add up together, this wave will be bigger than either one of these 2 sources. Now the opposite will happen if they are not aligned though. So if you get a peak and a trough that are aligned, so these waves are not completely lined up nicely. Remember here, look, peak and a peak. These will add up. This and this will cancel each other out. So you see these dead lines in the middle here, where it looks like there's no waves at all. It's because there isn't. The peak from, say, the left-hand source has lined up with the trough from the right-hand source, and they've just cancelled each other out perfectly. Again, we will do more work on this kind of stuff, especially when we go back to school in a few weeks. Okay, we'll have practicals to sort of address any gaps in knowledge, but for now it is just we need to get the knowledge. The last thing you need to know that going from different mediums, for example deep water to shallow water, from air into glass, waves will change direction. For now, that's all you need to know. Waves will change direction. They can change direction. And we won't go too much into diffraction because we are going to do that practical at school. But if you'd like to look and see, because I think I like these images, they look pretty cool to me. If you go look at the next slide too, you can see what happens when the gap gets smaller. But that is everything I need you to do. So it's a lot of knowledge. So remember, we're doing about transverse, longitudinal, about the required practical. Make sure you know this here. Make sure you know this. How do you measure the speed of? Sorry, don't do sound waves in air. That's like an application. The one that I want you to focus on, the knowledge, is the required practical, which is water waves. Okay. We'll discuss applications later on when we get back to school. So today, just make a few notes, just watch the videos, send your notes back to me, confirm that you've watched the videos, and you're done.